अरे यश भाई आप तो अलग ही लेवल पे चले गए हैं. बाय द वे, ये एक नेबरिंग गैलेक्सी का वो है, प्लैनेट जो कि लाइक मोस्ट ऑफ सैटर्न से मिलता है. दिस एंड दिस. सो yeah, if we look at this closely, we'll be able to understand कि इसके कंपोजिशंस क्या है. और यहाँ पे साइड में देखो इसके पैरामीटर्स लिखे हुए हैं, राइट. सो बेसिकली ये सारे पैरामीटर्स लाइक ऑर्बिटल पीरियड क्या है इसका, इसका डे ड्यूरेशन क्या है, इसको बने हुए कितना टाइम हो गया, इसकी ग्रेविटी की पावर क्या है. सो लुक एट दिस पैरामीटर. इट इज़ 18.735 जी, राइट. सो ये इसका नॉर्मल ग्रेविटी है. सो this much force will be applied when you will land on this particular planet, so you can understand the composition. And let's suppose हमें किसी और planet पे जाना है. So this looks good, but we can explore other galaxies as well. Let's straight away go to Andromeda. So we'll try Andromeda, and this is the Andromeda galaxy. Let's straight away go there. So we'll be finding the relative planets as well as the galaxies. So we can straight away just you can see the traveling time and how we are going there. So let's test it with a planet or something. Let's choose a sun, if it can go there. So this is also a planet. You can see that is the massive star that is hosting it. And this is not a planet. This is more of a what we call as asteroid, but it also also has the capacity to become in like a planet, because it should be in the initial phase, so it can attract mass and probably become a planet. So yeah, this is it. And also we can choose to move over to other planets, such as let's take any random planet. Let's take AOCSB. So yeah, look at this, how bright and beautiful this particular star is. So yeah, it's quite good. And we can land on the surface. So if we'll go close to this, we can straight away land on the surface, and you'll see how the things look from the planet, right? And you can see how glorious it is looking, including the stars and all of the things on both of the sides of the planet. Let's just say that we want to go to a planet named, let's explore Earth first. Why to move anywhere else, right? Earth is our home, and we should first explore that. So yeah, this is our beautiful Earth with all of the continents, land and atmosphere in place. You can see the overall composition. Here at the side you can see the temperature, atmospheric pressure, gravity, age, solar day, all of the essential parameters. What's the diameter of it, what's the life of the planet, and what's the class of this planet. So Earth basically belongs to the temperature marine terra with life. Like it has the capacity to host life, and it can easily give birth to different kinds of organisms that can produce life in future. So do let me know when you go to, well, I can see. Okay. We'll think about that later, but let's just see. And so let's land on here so we can understand. So this is the C portion, I guess. Yes, we have landed on C portion. So probably we can increase the velocity and we can move towards the flat portion of the earth, so that we can see some creatures. Although this is also looking good, but let's go back and maybe I should enable the atmosphere. Yep. And also let's now move to the Mars. So this is the rocky planet that we are focusing to establish life upon, although the things are not quite as easy at their looks, but I simply believe that it is possible, but not in our lifetime span, because it's very far, and the objective of making it to the Mars is still like very impractical, because we'll be needing a lot of nukes, a lot of resources. We will be devoting most of our what we call as economic revenue in generation of uh, the machines and explosives, so we can terraform Mars. But I think it's a very illogical thing as of now. So yeah, I think that it's still a red flag going to the Mars. Maybe you should focus on Earth. But anyways, the thing is, probably we should like focus on Earth, as for what I can say, because there are not much elements on Mars that can cater life. There has been life on the Mars, there is no doubt in that, but going from scratch, building up all of the things, establishing environments, putting in all of the factors, making sure a sustainable life is possible, growing crops, it's just too much of work to do. And looking at the pace at which the destruction is happening at Earth, I don't think that it is achievable in our lifetime, or in this generation's time. This is what my calculation says. Yeah, so let's just explore some other planets, removing these random thoughts from the stream, and let's just see where we can get. Also, you can see the craters that are formed on Mars. So these are the signs that there were like substantial water bodies in some form at any point of time when there was possibly life on the planet. So yeah, this is that. And also you can see the cutting in the surface. So this comes when there are significant water bodies on the surface. So I guess that's why it's still a subject of interest to a lot of scientists, because it has some very promising things that lure the scientists in different formats to explore, to research, to maybe get in the probe and go there. But I think that there is still a very long way to cover. So yeah, this is the Mars. Let's move to our other planets, like let's say Uranus. So let's move to Uranus. Although it has rings, but it is very light in nature. So is it from our galaxy? I just wanted to make sure. Let's check. um yeah, it is from our galaxy, because there are multiple Uranuses, right? There are Uranus, similar looking planet to Uranus. So you can see the list: Uranus 1, Uranus 2, Uranus 3. So scientists are just very lazy to name them a different planet, because every day we find a new planet. So it's very hard to give them different names. But yeah, like we match the current properties of a planet, and then we categorize it in different formats, and then we just put a tag on it and simply like leave it. So okay, let's land on Uranus. So probably we'll be able to understand the planet in much better depth. So these are the beautiful rings of Uranus. And coming to the practicality, these are gas giants. So even at the base of this planet, you won't be finding much of the activity, because all of it is gas. Yeah, one very famous thing about Uranus is that it has diamonds that rain on the planet. So yeah, it's quite true. But the thing is, it is not very ideal to even go for research, because the temperatures, and even we can't land because it's a gaseous planet. So even if we manage to circle around it, or for to land on some portions, let's say just like hovering over the planet, it can be possible, but not like in-depth research can be done on this planet. So yeah, this is that. All right. Most of the Uranus looks like this only. If we add some clouds to it, and if we add some temperature, basic elements of the planet, then also we won't be able to find much of the interesting things that will be happening on the planet. So yeah, that's that. And let's move on to other planet. Not planet, let's go to Titan, because it is one of the very interesting moons that most of the scientists are quite curious about. This is Titan, as you can see, and it revolves around our gaseous giant. Where it is, let's find. We can see Earth. If I'm not wrong, that is Earth. No, it is not Earth. Okay. Yeah. So this is the planet is Saturn, and that was the Titan. So basically, it is a moon of Saturn that revolves around it. And just look at it, how beautiful Saturn is. And believe me, it is a very better experience when you will see it in let's say telescope, because the rings and the planet, when it moves in a collective form, it looks so beautiful that you will be amazed how good a planet can look. Even if you'll get a chance to see Uranus in some chance, like any observatory or something, you won't be able to move from the telescope once you see it. So it's that beautiful. So yeah, can we land on it? Yes, we can. So this is the gaseous giant as well, like Jupiter. So most of the things are like this, but look at these beautiful rings that have surrounded the whole environment. Suppose you are waking up to this environment every day. how beautiful and good it will look, right? That is our sun. All right. Okay, so let's see what else we have got. So move to any random planet. Let's say we take a very strange planet and let's explore the landscape of that planet. So let's suppose what we call as super Earth, right? That's a very common term. So if we'll search super Earth, these are the suggestions. Let's go to these stars maybe. Let's see how they are formed. Okay, so you can see what I can see is that these both are about to clash, if I'm not wrong, because you can see what stage they are in. They'll probably collide with each other and then form a pulsar. So if you don't know what a pulsar is like the formation phase of a star that ultimately becomes a black hole at the end. So this is that, and probably because they'll be attracted and they'll be exchanging the energies. So yeah, this is that. And let's go to a planet that has some terrains, so we can probably see something good. So let's just say Saturn. So you see that this is a dwarf moon probably. So we need to first find a galaxy that can host some planets. We can simply go there and we just need to click here and we'll be seeing what are the bodies that are lying there, right? So let's just go to this. Okay, it is more like Uranus, and I guess this is a rogue planet, if I'm not wrong. What it's saying that frigid airless fair. Okay, so it is, these are like bodies that don't get hosted by any of the like mega bodies, so they just stay in the system. They don't act very uniformly, but they still stay there. They follow up all of the movements and they get influenced by the normal astronomic events. So yeah, this is that. Let's go to this planet, which is one of the most common and celebrated planets in the galaxies. Okay, so you can see how the host is looking. This is the host, I guess, if I'm not wrong. And it doesn't has much elements. You can see these are only 2 elements. So let's just see where else we can go. Whoa, look at these rings. This fading effect in this looks so good. Wow, let's go to this galaxy and see what's lying there. Whoa, This is simply so mindful and so gorgeous to look at. I mean, just wow. Look at the color composition. Although I know in reality these things are quite different. This is probably published by NASA, but yeah, we can still enjoy the view. There is nothing wrong in that. So this is nebula. Yeah, all right. This is nebula, and you can see the kind of clouds that are there. This is just so awesome. These are some of the stars that are in this planet. Sorry, in this nebula. So nebula is the like formation cloud where all of the elements get collected and they form a massive planets or let's say stars. It is like forming body of the universe. And we also have this nebula that is just staring at us, right? So this is also nebula that is like forming some stars in it. Wow, these two collectively just like look so good. Yes, maybe you can make them your wallpaper for the phone or PC. If you are still there on the stream. Let's go to this. Oh my god, look at this. Just simply look at this. Wow. How dramatic this looks. Like you can see what are the clouds, how they are changing. Just so glorious to look at. Can we land on any of the stars? Let's see. Okay, so it is in very initial stages. You can see it just has like basic core, and these are very small to land on. They haven't gained their mass. So yeah, these are like that. And you can see the whole system. Now we are inside the system, right? Earlier we were looking from exterior side, but now you can see it has a lot of small looking. Yeah, it is mesmerizing. Let's go to this. Okay, this is also the same. All right. I guess we are done with nebula. Let's go to two more planets and then we can end this stream. So let's choose a planet. Jennison. Yeah, we can go on Jennison, but okay, let's go with that. This is the one that I showed earlier in the stream because it has a lot of colors, right? And it hosts around a, if I'm not wrong, it is a black hole. Okay, it is a dwarf. So it is hosted by a dwarf. And if we land on it, whoa, just look at this, how beautiful it is from the surface of this planet. This is the view that we get. just it is just so vibrant to look at, and you can look all of the stars and uh, the big planets that are there. And I think the planet distance in this particular system is very close, so that's why you can see the planets at a very close range. You can see 1, 2, probably it is also a planet of this system, 3, and that is the nebula. So yeah, it's just so amazing to look at this. Okay, all right. Let's go to another planet. Let's suppose let's type in planet, so it will suggest where we can go, not asteroids. Okay, so maybe we need to type a name. Let's say we want a Earth, and Earth 1, it is a moon. Okay, let's go to this planet. Yeah, it looks like Earth. Does it have water by any chance? Diameter, mass, torrid Jupiter. Oh, probably it is also a gaseous giant, or it has a surface. Oh, it is a gaseous giant. You can see the core right from the start. You can see it from standing on the core. All right. Okay. The sky seems good. Okay, it has some water formation on the surface. All right. Let's look it from outside. What's the scenario? Okay, so let's go to this red area. Let's land here and see what's there. Okay, it looks like it has some solid bodies, but no, I don't think so, because these are all gases. So yeah, I don't know, it's a very weird composition. Maybe I need to study further about this planet, but it has a very weird kind of combination altogether. And the sky is blue. It means that there are some elements that are filtering the light of the host planet. Quite interesting. Alright, so this was for this particular stream. Although there were only 2 folks, but I hope that you guys liked the stream, and I'll try to post some these kind of content, and I'll try to regularize these kinds of stream in order of your comments or any specification that you like. So probably I'll explain that, and we'll talk about more of interesting topics and matters that we can discuss and get on to a particular conclusion. So that's that. Thanks for watching.